So quiz 1013 we'll be taking tomorrow. And so just kind of what have we been doing up to this point? What did we do this week is the major focus, of course, since the last quiz. And so I wanted to point these things out so you remember. They should all be in your notebooks, of course. But one of the biggies was talking about conservation of matter. And so we did this stations lab. We did all these different stations where we were checking out these changes. Try to figure out what's going on. Of course, you know that we're focused intently in this unit about matter. We're focused so much on the particles, the actual particles. So the particles, when we find their particles really are just matter, and when we find the amount of matter in an object, that's really the mass. So we're trying to figure out what happens to mass during those changes. And what we should have came up with was an idea that during these changes, the amount of matter, which we call mass, does not change. And I'm going to put in a system. Because we did have a couple of stations where we had discussed this and we said, well, it looks like the trend is that it lost mass. And then we talked about how, okay, were gases produced? Did we have a way of keeping those gases contained? If not, then there are going to be particles leaving the system, which would account for us when we find the mass of the system before and after. It looks like there's a loss in mass. But as long as we keep all the particles we start with in the system, there shouldn't be a change. If it's a physical change, we're just changing the size, the shape, the phase, like melting it or freezing it. And even in a chemical change, all we're doing is taking the particles we have, breaking their connections to other particles, and rearranging them and attaching them to something new. But whatever we had before, we still have at the end. Okay, this is conservation of matter. So, of course, you guys know models are big. We're going to have to be able to do a model of this. And now, if we think about this, if we're trying to show this in a model with particles, and we do a specific number of particles, this is very, very important. The number of particles before should equal number of particles after. Now, are they all still in the system? I don't know. You know, we talked about the yeast and the hydrogen peroxide. So if I wanted to show conservation of matter in this example with yeast and hydrogen peroxide, then maybe I could say, well, let me think about this. We lost some of the particles. Maybe in my beginning diagram, which I want to do multiple views, and I love those blow-up views, maybe I do 12 dots in the beginning of the diagram. And then at the end, maybe I show that there's only 10 dots in the yeast hydrogen peroxide mix, and then maybe I show 2 dots that escaped into the air. But there's still 12 there, isn't there? Okay, so I have maybe 6 yeast particles, 6 hydrogen peroxide particles. I mix them and I show over here, I show 5 of each maybe, and then a couple leaving. That would be good. So my before particles should equal my after particles. All right, that's conservation of matter. All right. The other thing we've been working on, of course, is measurements. So in our measurements, we want to make sure we measure accurately and measure with correct precision. All right. So we should be able to look at a graduated cylinder and say, what is the measurement with the correct precision? That's a biggie. That's what we're talking about. Precision always goes one more. So we look at for the whatever my measuring device is, what's the smallest mark on here, and then estimate one digit further. Okay? And that is pretty much it for quiz 3 right there.